Now this is the second video of your chapter 5th, light energy. Now in the last video we had studied about the rules of refraction at the end. Again I am telling you there are two rules. A ray of light which is traveling from a rarer medium to a denser medium bends towards the normal. For example, if the ray of light is traveling from air to water. Then the second rule is a ray of light traveling obliquely from a denser medium to a rarer medium bends away from the normal. But if the ray of light is incident normally, it goes, means it makes an angle of 90 degree with the surface of separation of the two media. It goes undeviated, that is, it is going to travel in the straight path. Now in this video I am going to tell you about some of the effects of refraction of light. Now you must have seen it if you are going to put a spoon or a pencil in a glass of water. You find that the pencil seems to be, or a spoon seems to be bent and little raised. It is all because due to the refraction of light. Now we are going to study some more effects of refraction of light. First, we have discussed just now that the pencil appears to be bent and shorter when it is seen from the top. Now, second effect of refraction of light is, suppose if you keep any object in a glass or in a vessel containing water, suppose a coin is immersed in a glass of water or any other object, it appears to be raised. As you see in this also, the pencil seems to be raised. And why it happened so? It is all because of the refraction of light. And the third effect of the refraction of light is that the swimming pool which is filled with water appears shallower. Shallower means it seems to be less deeper than it actually is. We think that the swimming pool is not that deep, but it seems to be less deeper, but in actually it is not. So that is why it seems to be shallower. Now these are the three effects of the refraction of light which may come as reason in the exam. Now we are going to study about two laws of refraction. Now there are two laws of refraction. It is governed by two basic laws. First law says the incident ray, the normal at the point of incidence, means the normal which is drawn at the point of incidence, and the refracted ray, they all lie on the same plane. But they are not in different planes. They are on the same plane. Now, second law is for a given pair of media which you are taking as glass with air, water with air, media of different densities, the ratio of the sign, it is read as sign, ratio of the sign of angle of incidence. Actually, what is sign? It is a trigonometrical ratio which you are going to study in your 9th class in maths also. The ratio of the sign of angle of incidence to the sign of the angle of refraction is always a constant. That is, sin I means sign of the angle of incidence. This is for ratio we divide only. So the ratio of the sign of the angle of incidence to the sine of angle of refraction is a constant. That is, if you are going to divide for different angles of incidence and angle of refraction, and you are going to take the values of their sines, you are always going to get a constant value. Now this second law was stated by a Dutch astronomer, Wilbrod Snellis. So that is why it is also known as the Snell's law. So the second law of refraction of light is called as the Snell's law. Only the second law, not the first one. Second law is known as the Snell's law. And this ratio, which you get by dividing sin I upon sin r, I told you it is always a constant. And this constant, we call it as the refractive index. So sin I upon sin r is the refractive index. So value of the constant is fixed for a set of two transparent media and depends on their nature also, nature of the medium. It is called as the refractive index of the second medium with respect to the first. What do you mean by second medium with respect to the first? That is, if the light is traveling from air to water, so water is the second medium with respect to air. And if the light is traveling from air to glass, glass is the second medium with respect to air. So sin I upon sin r is called the refractive index. Now there is also one more definition for the refractive index of a medium with respect to air, with respect to the air, if you take. So what is refractive index of a medium with respect to, not necessarily to take vacuum, you can take air, because speed of the light in vacuum or air is the same. So it is also defined as the refractive index of a medium with respect to air is also defined as the ratio of the speed of light in air to the speed of light in the given medium. So this is, suppose your medium is a glass. So here we are going to write refractive index as G, writing G, and this is the symbol which is used for the refractive index, which we read it as mu. This is the symbol which we read it as mu. So this is a symbol for the refractive index. So the refractive index, definition of refractive index, you can also say it is the refractive index of a medium with respect to air is speed of light in air or vacuum to the speed of light in a medium. Suppose if I ask you what is the refractive index of glass, so you are going to say that the refractive index of a glass is the speed of light in, refractive index of glass with respect to air is the speed of the light in air to the speed of the light in glass. Now we are going to study about the refraction of light through a glass slab. Now when school will reopen, I will show you how does the glass slab look like. It is a rectangular piece of glass, rectangular solid piece, somewhat looks like a cuboid. That is a glass slab. So now the refraction of light, we are going to study about the refraction of light through the parallel sided glass slab. And I told you in your book, in the figure 5.7, it is written, it is glass prism. So I told you to cancel prism and instead of that write glass slab. You may be asked to draw the diagram also in exam to show the refraction of light through the parallel sided glass slab. Now PQRS is a glass slab. A light ray AB is incident on this, which is coming through the air. It is incident at this separation of the medium PQ. So this becomes the AB becomes the incident ray, and at the surface of separation as it is traveling from the rarer medium to the denser medium, glass is denser, so it is going to bend towards the normal. So this BC is called the refracted ray. And this refracted ray, after passing through the glass, will come out again into the air. And the ray of light which comes out into the air again, we call it as the emergent ray. So CD is the emergent ray. So you are going to write you can write separately also that AB is equal to incident. Draw a diagram and write separately. AB is equal to incident ray, BC is equal to refracted ray, CD is equal to emergent ray. And as I already told you, the angle between now at this point B, which is the point of incidence, normal has been drawn as NX. And this is also the point of incidence, that is the separation of the surface of two media. So C is the point of incidence, and at C also a normal has been drawn as MY. So the angle between the incident ray and the normal, written with small I, we call it as angle of incidence, that I have already told you in the first video. Angle between the refracted ray and the normal is called the angle of refraction. Now this emergent ray makes an angle E, small e written, with the normal, which we call it as the angle of emergence. Now you see that the incident ray entered into the glass and then came again out into the air. So it has changed its path. Suppose there is no deviation. So then it is going to follow this as it is shown with the dotted line. It should have traveled like this, as shown with the, if it is, there is no deviation, it would have gone like this in a straight path. And this incident ray, if I produce it backward, it will be always parallel to the emergent ray. Now if there would have been no bending, it would have gone straight. Now this distance D, because actually bending has taken place, this distance D, we call it as the lateral displacement. Means it shows how much the light ray has displaced from its original path. So this distance we call it as the lateral displacement. So you may be asked to draw the diagram, and in the diagram also you can, as I have done shown all the rays and the angles, you can do like this also. And this angle small e is called the angle of emergence. So this is the refraction of light through a glass slab. Now for that, an activity is also shown in your book. You only go through the activity because you don't have to do any activity, but it is shown that how we do refraction in a glass slab. Now we are going to study about the refraction of light through a glass prism. Refraction through a glass prism. Now glass prism is also a solid which is made up of glass, and it has got, how does it look like? Again, when school will reopen, I will show you the glass prism also. It is a glass block that has a triangular cross section, which we call it as the base, as it is, you see, it is triangular cross section, which we call it as the base, and it has got 3 rectangular faces. It has got 5 faces, 2 triangular faces and 3 rectangular faces, and these rectangular faces we call it as faces, and triangular cross section we call it as the base of the prism, and the refraction takes place through the rectangular faces, and this angle we call it as the angle of formed in the triangle, we call it as angle of prism. Now see the diagram. This may also, you may be asked to draw. As you see now, how it is written also. You can write it separately or you can show it in the figure only. What is xy? You can see with the arrow, xy is the incident ray. And it is written also, xy is the incident ray. And now this is the surface of the separation of the two media. So light is going to bend here at the point y, and it is going to bend towards the normal. Now at point y, which is the point of incidence, normal n1 has been drawn. Normal means which makes an angle of 90 degree. So it is bending towards a normal. So this yz is called the refracted ray, as you can see in the figure also. When this ray is going to strike this surface of the glass, now it is going to emerge out from the glass into the air again, and z is the point of incidence. Again a normal has been drawn as n2, n3. Now as I told you, it is going to travel now from denser to rarer medium. It is going to bend away from the normal, and ZR is the emergent ray, as you can see in the figure. ZR is the emergent ray. And what is this small I between the normal and the incident ray? It is called angle of incidence. Angle between the refracted ray and the normal is called angle of refraction. Angle between the emergent ray and the normal is called the angle of emergence. This is all is written here also. Angle I is angle of incidence. This angle R1 and angle R2 will be equal. They are the angle of refraction at the first phase, and then at the, this is the first phase, this is the second phase. E is the angle of emergence. Now if I produce the incident ray backward and the emergent ray backward, as shown with the dotted lines, you see they are intersecting at this point. Now the angle between the incident ray and the emergent ray, we call it as the angle of emergence. So this small e is called the angle of, this is called the angle of deviation. The angle between the incident ray and the emergent ray is called angle of deviation, which shows that how much your incident ray has been deviated out. Angle of emergence was this one between the normal and the emergent ray. But this is called angle of deviation, and as you can see in the figure, it is written with small letter d also. And what is this capital A? It is the angle of prism. And what is n1? It is normal. What is n2, n3? It is also a normal drawn on the second phase. At n1 is drawn at the point y, and n2, n3 normal has been drawn at the point z. So this, like this, you can write separately also, you can show it in the figure only. So this is the refraction through a prism. You can see in the enlarged form also like this, that this is the angle of incidence, this is angle of refraction, this is angle of between normal and emergent is the angle of emergence, and incident ray when produced backward and the refracted emergent ray when produced backward, they are meeting at the point E. The angle between the incident ray and emergent ray, we call it as the angle of deviation. Now with the help of the prism, we are going to study about the dispersion of white light. You know that white light is made up of 7 colors. But as the white light is if it is in the air, we see only the white light. Because when it is going to enter into another medium, then only refraction will take place. So when this white light, if it passes through a prism, because we have seen that the this prism deviates the ray of light. So if a beam of white light is incident on a prism, it gets split into its constituent colors. And you know white light is made up of 7 colors. So it is going to split into its 7 colors. All the 7 colors will deviate out. So what is dispersion? This process is called dispersion. So what is dispersion? Phenomena of splitting of white light into its constituent colors is called dispersion. And who was the scientist who studied about it? The scientist was Sir Isaac Newton. Now this band of 7 colors which we get after dispersion, we call it in a short form as Vibgor. And you must be knowing about the different colors of the Vibgor. V stands for violet, I stands for indigo, B stands for blue, G for green, Y for yellow, O for orange, and R for red. And if you are asked to write about the 7 colors of the spectrum, and this band of 7 colors of we call it as band of 7 colors is known as spectrum. And if you are asked to write about the 7 colors of the spectrum, you are not going to write it that you write yellow before. You are going to write it in this order only. It is not that you write yellow first, then green afterwards. So you learn this word Vibgor, which is going to help you to arrange the colors in the order. Now you see in this, violet is at the beginning and red is at the end. Now why does this dispersion takes place? Because in this you will find that violet is deviated the most and red is deviated the least. And in the same way you can arrange it in the descending order, that violet is deviated the most, then indigo, then blue, then green, then white, yellow, then orange, because all the colors have their own refractive index. And the speed of the light is different in different colors. So this is the only reason for the dispersion to take place. So why does dispersion occur? Dispersion of light occurs because the refractive index of a medium with respect to another medium is different for different colors. Or in other words, you can say that the refractive index is different for different colors. So red color deviates or bends the least. As you can see in the diagram also, red band is at the top and violet is at the bottom. So red is not deviated that much as the violet is. So which color deviates the least? Red color. And which color deviates the most? Violet. This is why red forms the top band of the spectrum, as I have shown you in the figure also, and violet forms the bottom band, like this, as you can see in this figure also. So this is how dispersion takes place. Now, one of the natural example of the most fascinating or most common example which we find in nature of dispersion is rainbow. Just after the rainfall, suppose it is raining and suddenly the sun comes out, because light is required for dispersion, takes place of light only. Suppose it is raining and suddenly the rain stops and the sun comes out. Sometimes you must have seen this band of 7 colors in the sky, which we call it as a rainbow. So it is the example of the dispersion of light. How is a rainbow formed? Just after a rainfall, there are tiny droplets of water which remains in the atmosphere, which are suspended in the atmosphere. They remain in the atmosphere. And all these droplets of water, they act like tiny prisms, because I told you dispersion takes place through prism. And these droplets are tiny triangular prisms. They are tiny prisms. So when sunlight passes through these droplets, which act like prism, it undergoes dispersion. So with a large number of water droplets contributing to this phenomena, we get a huge continuous band of 7 colors as rainbow, which we call it as rainbow. So this is what you have to study in the refraction of light. In the next video, I am going to take up the spherical mirrors, which we call it as the curved mirrors also. And I am going to give you a assignment also based on whatever I have taught. So do that assignment also. In the next video, then I am going to start up with curved mirrors.